Today we're talking about special cases of equations that have variables on both sides. So today I'm asking, how do I know whether an equation has infinite solutions or no solutions? These are special equations. If you get a weird answer at the end, you'll have a special way to answer it. So identity or infinite solutions. If you end up with something that looks like this, like 3 equals 3 or 5 equals 5, this is true, and so your final answer, you will say, so because this is true, you will say infinite solutions or identity. Another thing that you could say is all real numbers. So that's if you end up with something that looks like that. If you end up with something at the end that is false, like say 2 equals 5, which is not true, you can put a slash through it. That's false. But your final answer, you will say no solutions, because there's nothing that works. The variables cancel out, so there's no possible number that works as an answer. Let's solve two equations as an example. You will solve these equations exactly the same way we solved yesterday. So if you draw a balancing line down the middle, first thing to check for, can I distribute? Yes. So we're multiplying. Half of 4, or 1/2 times 4, is 2, so 2x. And half of 6 is 3. There's a negative, so we're going to make it minus 3. And that's still equal to 2x. You can't combine like terms, so we'll move our variables to one side. And we do that by doing the opposite of what we see. So I see positive 2x. We're going to subtract 2x. And the thing is, when you do that, 2x minus 2x is 0, and that cancels out. So those both go away, which is kind of a problem. You have negative 3 left. You got to put something over here, so you put 0. Now look at that. You have negative 3 equals 0. Is negative 3 equal to 0? Are those the same? No. This is false. So because it's false, your final answer you're going to say is no solutions. Because this equation doesn't work. You end up with something at the end that is not true. Negative 3 isn't the same thing as 0. So your final answer is no solutions, and you leave it like that. You got to say no solutions for it to be counted as fully correct. So the last one was no solutions. This one, we'll see what it is. I draw that balancing line down the middle, and I check, can I distribute? I can. On the right-hand side, I get negative 4, and then negative 2 times negative 5m is positive 10m. Bring down the stuff on the left, and now we'll keep going. There's no like terms on either side, so we'll go ahead and move our variables to one side. We're moving the m, so I'm going to move this one. It's positive, so I subtract it away to take it away. 10m minus 10m is 0. 10m minus 10m is also 0 over here, which leaves you with negative 4 equals negative 4. Is that true? That negative 4 equals negative 4? Yes, it is true. And so you have to say for your final answer, you have several different options. But you got to give me a phrase to end it. This means that there is an infinite amount of solutions. Anything works. Other things that you can say, identity, or all real numbers. And we have a fancy symbol for that. If you're interested, the symbol for all real numbers is this weird R. So you have to say one of these three things, please, for it to be counted as correct. No, don't have to say all three. Choose which one you like the best and say that. But if it works and it ends up being true, which is two numbers because the variables cancel out, then it's identity. Okay, last thing I want to point out. Look at your equations. Here and here. Notice how on the one that has infinite solutions or all real numbers, they're exactly the same. 10m minus 4, negative 4 plus 10m. These are the same. On the other one, it's almost the same variables, but there's a different number there. That's what makes it not work.